Hi folks, here we are. Welcome to the first installation of my attempt at delivering Mastercam education to you guys online. So please bear with me as I struggle through this process. I've had to learn some tech in terms of screen capturing, recording, so on and so forth, editing. This may be somewhat choppy, but one way or another, I will get you guys the information you need, and I will be there for you in order to help you through the next weeks in order to successfully complete this term. So, first things first, let's move on in our Mastercam learning to exercise number 5. So this is tutorial number 5, exercise number 5. There'll be links on Blackboard for you to download this exercise instruction. There'll be links to the solid model that we're going to be using to generate this program. And I'm going to break this down for you into a few key functional elements. So I will be publishing a number of video clips that will, as a unit, cover the process of creating a Mastercam program for this part. I will be approaching things a little bit differently than what you've done. One thing I want to do for you is show you how to strategize from a high level point of view your manufacturing project or your programming project. I want to do the thinking up front, and then we can use the plan we make in order to systematically create a Mastercam program to actually execute the programming task at hand. So what we will do is we will look at bringing the solid model into Mastercam. We will look at orienting that solid in the appropriate orientation so that our work offset or our work zero is in the right place. We will look at what tools we need to execute all the specific tool paths that are needed to make this part. And when we look at those tools, we're going to be thinking about tool type, tool diameter. We're going to be thinking about the length of the tool and the reach. So we have a situation here where we have a very deep pocket with features on the bottom of this pocket that we'll have to reach with our tools. And we're going to be thinking about speeds and feeds. We're going to look at the operations necessary to execute this part, and then we're going to pull all this together into one comprehensive process. So let's have a look at this part in a little bit more detail. Before we look at these numbers that you're seeing here, let's look at the 3D model of this and get a sense of exactly what's required for us to pull this off. So this is our part. You can see that there's some significant reach necessary from the top surface of this part to the bottom surface, or from the top surface of this part all the way through to these holes. So we're going to try to execute this part in 3 operations. So setup 1 will be looking down. If we're looking at our orientation as if we're looking at it in the Z direction. So we're looking at this axially to our tool. Setup number 1 will be in this orientation. Setup number 2, we'll spin this around and set it up like this. Setup number 2, and then setup number 3 like this. So let's look at those in a little bit more detail. Setup number 1. If we look at our drawing here, we have a work offset location in the center of the part. And if you look down here, it's at the top of the part. So our G54 for op 1 is top of part on center. So let's look at that in Mastercam. So we can look at this from our top view here. We need to show our axes, show our gnomons, whatever the heck that's called. And we currently have our work offset, and I'm going to show you how to bring this in and manipulate it, but I just want to look at this part for now. So we have our work offset in the correct location. So from here, we're going to remove all this material that's in here in a roughing operation. So you can see I have Excel set up on the right here. I like to work this way. I like to develop a plan in Excel. So I like to make a tool list of all the tools I'm going to need to pull this project off. And I like to make an operation list with the number of setups and the toolpath type. So I'm making a plan ahead of time. So let's make our operation list, and then we'll go back from that operation list and we'll generate an appropriate tool list looking at the actual numbers. So setup number 1, with our work offset in the center, we're going to do a roughing operation to remove all this material. So setup number 1, we're going to do this toolpath type will be roughing. Actually, let's just call it the type of toolpath. So we'll do a 2D high speed dynamic mill operation, and then we're going to rough out the bulk material. And we're going to leave stock on the walls for finishing. So setup number 1 still. The next toolpath type will be a contouring toolpath where we finish the walls. So then once we have this pocket all cleaned up, we can do this small cross-shaped pocket in the bottom here. So still in setup number 1, we'll have a pocketing operation where we cut the pocket. Still in this setup, we're going to spot drill the holes, and we're going to peck drill the holes, and then we're going to tap these 2 holes here. So if we look at the drawing, these 2 small holes are tapped holes, and the 2 larger holes are 1/2 inch through holes. So we'll spot drill, drill, and tap. So we need to have a drill / counterbore for our spot drill the holes. Still in setup number 1, we're going to have a peck drill cycle where we peck drill the holes. We're going to have another peck drill cycle. So we'll peck drill here small holes, and then we're going to peck drill large holes, still in setup number 1, and then we're going to have a tapping cycle in setup number 1 where we tap the small holes. So now we have an operation list currently populated for setup number 1. I think that's everything in setup number 1. Setup number 2, we're going to set up like this. We're going to put our work offset in the top left corner, top surface, top left corner. And this operation will involve contouring this fillet and pocketing these 2 triangular holes. So setup number 2, we're going to have a pocketing operation where we cut the triangle pockets, and then we're going to have contouring operation where we cut the fillets. So that's op 2. Then we're going to flip the part over for op 3. Op 3, where we're going to do, again, a pocketing operation. I'm just going to cut, paste, do a pocketing operation where we cut the triangular pocket, just the one of them. And then we're going to contour the fillet. We're going to circle, mill, cut the circular hole. This is all going to be in setup number 3. And then we're going to have to spot drill, drill, and tap these holes. So I'm going to just copy from above, paste. I'll get rid of that row. 3, 3, 3. So we're going to drill counterbore cycle for spot drilling. We're going to peck drill the holes, and we're going to tap the holes. So we have an operation list. Make sure you save often. Now from this operation list, we're going to combine this strategy with our actual numbers in order to generate a tool list. Okay? So let's start from the top and work our way down. We're going to organize this according to end mills, drills, and so on. So we're going to do a high-speed dynamic milling operation to rough out this bulk material. So we'll use, that'll be tool number 1. It'll be an end mill, square end mill, OD 1 inch. Now we have reach issues here. We need to reach down 3.25 inches with this tool. So we're going to have a 4-inch flute length. Sorry, we'll have a 3 flute end mill, a 4-inch length of cut with a 6-inch overall length. Tool number 2, square end mill. We'll finish the walls with a 3/4 inch end mill. 3 flute, and again, 4-inch length of cut, 6-inch overall length. Tool number 3. Actually, you know what? Let's add the tool numbers in the end. So we need to cut the pocket. So we need a square end mill, 0.25 1/4 inch end mill. We have 1/8 inch radii on the corners here. So let's zoom in. This pocket has 1/8 inch radii. So we need a 1/4 inch diameter end mill to get in that pocket, and it needs to reach all the way down. So we're going to have a 1/4 inch end mill, 3 flute, which has a 3.5 inch length of cut, 5-inch overall length. We'll leave a space because we need to make a drill. So we're going to need a spot drill, a drill, another drill, and a tap. So what's our biggest hole? Let's try to find a spot drill that's going to work for all our holes. This is 1/2 inch diameter, 3/8 tapped hole. Here we have 3/8 tapped holes. So we'll choose a 3/4 inch spot drill, 0.75, 2 flute. It's going to have to reach all the way down here, the spot drill. So we'll have a 4-inch length of cut, 6-inch diameter, or 6-inch overall length. Now we have a drill. This 1/2 inch drill, 0.5. We're going to have to drill all the way through, so 4 inches plus some, right, to clear the top and to go all the way through. So we're going to need a 4-inch depth of cut plus whatever tip comp we use. So let's say 4.5 inch 2 flute for sure, 4.5 inch length of cut, 6 inch overall length. We're going to need another drill. This is going to be the tap drill for a 3/8/16 tapped hole. You guys all know how to find a tap drill size by using the tap drill tables. So it's going to be a 0.3125 inch drill, 2 flute, 4.5 inch, 6 inch overall length. So we have our 2 drills. Now we need our tap, right? So we're going to go tap, right hand tap, and that's a 0.375 tap, 1 flute, 2 flute, whatever. Again, it's going all the way through. So 4.5, 6 inch. So we have all of our tools now for setup number 1. Let's look at setup number 2. We're doing a pocketing operation of these triangles right here. Everyone can see that. We have a 1/4 inch radius on this top triangle and a 1/8 radius on the small triangle. So if we want to do them both together with the same tool, we should choose a 1/4 inch end mill. But we've made a 1/4 inch end mill up here that's really, really long. It's a very inefficient length tool. We made it so that we can cut this pocket down here. And we need to clear the top surface here. But we want a much shorter tool for doing other 1/4 inch end mill work. So we're going to make another 1/4 inch end mill. So I'll just make a space in here by inserting another row. It's going to be another 0.25 inch end mill, but 3 flute, but much shorter. So my length of cut will be maybe 0.75. And maybe it's a 2 inch long total tool. Much more rigid. Now you notice I'm organizing my tools according to diameter. They get progressively smaller in diameter. Same with my drills, progressively smaller. So I would like to have a 1/2 inch end mill, I think, in here for doing this contouring of the fillets, and maybe for doing the pocketing of the circle mill. So I'm going to make another end mill in here. Insert a row. I'll take these, drag them down one. Square end mill, 0.5. 3 flute. Length of cut, 1.25 or 1.5, whatever. This could probably be the standard Mastercam tool, 4 inch. So that's going to do our, we have a 1/4 inch end mill to do our pocketing operation in setup number 2. We have a 1/2 inch end mill to do the contouring in setup number 2. We're going to cut the triangular pockets. Here we have a 1/8 corner radius. If you look up here, so that'll be our 1/4 inch end mill. The 1/2 inch end mill can do the filleting operation here. The circle milling can be done with our 1/2 inch end mill. The spot drilling, we already have a spot drill that works. The peck drill, this is a 3/8/16 tapped hole, which we already have the drill and tap for. So this is our tool list. We can give these tool numbers now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have an operation list identifying our strategy. Ideally, this order will be followed at least relatively closely. And we have a tool list that can execute these operations. Now let's go one step further and identify our feeds and speeds right here in Excel. So we only need to calculate this once. So we're going to use an SFM of 800 for all of our end mill work, 600 for our drilling. Tap is a separate item. Inch per tooth, 0.008 for our 1 inch, 0.007 for our 3/4, 0.005 for our 1/2 inch. This is inches per tooth, right? 0.003 for our 1/4 inch end mills. And we'll stick with 0.005, 5 thou for our drilling. Now let's calculate our RPM. How do we calculate our RPM? Well, we have SFM times our OD already done this here. So we have our SFM times 4 divided by our OD. Sorry, brain fart. SFM times 4 divided by our OD, outside diameter, right? Now we can drag and do all of our RPM calculating by using our Excel calculating tools. Now our feed. Again, already done this. You can see here that I've rounded. So we're going to multiply our RPM times inch per tooth times our number of flutes. And then I'm going to get rid of the decimal, allow it to round. I don't really care about the direction. Now I have my RPM and my feed that I need in Mastercam. File, save. My tapping, I'll tap at 1000 RPM. And the pitch will control the feed rate. So I have a tool list. I have an operation list. I'm just going to get rid of some of these to bring that up. This is my strategy. I now have a strategy for machining this entire part. So let's go into Mastercam. Let's bring in that part. Let's orient it correctly. We'll have to set up our planes for our various setups. We'll have to create a tool list. We'll have to choose our machine, and then we'll get rolling. So I'm going to publish that as the second video in this exercise number 5 installation. This particular video resulted in us having a comprehensive strategy for machining this part, which includes our operation list, number of setups required, the Mastercam toolpath types we're going to be needing, the tools we're going to be needing. We've thought about reach. We've thought about feeds and speeds. Now we're going to pause this, and you can look for exercise number 5, installation number 2, for how to start doing this in Mastercam. Thanks for tuning in, and I'll get the next video done here shortly. Cheers.